Okay, so here we go. I want to turn this into a perfect trinomial square. Square root of x squared is x, center sign is plus. I need what's going to go there. Well, I'm going to take b over 2, square it. It's 2 over 2 squared, which is 1. So that says if I add 1, he's a perfect square, and the square root of 1 is 1. So it's x plus 1, the quantity square. Square root of x squared is x, center sign is minus, because this center is minus. The inner outers are going to be both minus. So that says I'm going to take b divided by 2, square it. It's minus 10 divided by 2 squared, which is minus 5 squared. Minus 5 squared is 25. So that says I add 25, and what goes here is the square root of 25, or 5, because it's x minus 5 times x minus 5. Whoops, there we go. So I want to turn this into a perfect trinomial square. Square root of x squared is x, center sign is plus. So b over 2 squared is 9 over 2 squared is 81 over 4. So that says add 81 over 4, and the square root of 81 over 4 is 9 over 2. It's what I squared. Now, the next two are fractions, and I know they're rather fearful. But when I look at b over 2, I can write him in two ways. I can write him as b over 2, or I can write him as 1/2 times b. 1/2 times b over 1. Anytime I have a fraction, that's the one I use. Because otherwise I'll have to invert and multiply. So again, if I had b over 2, and b is like on the bottom, the next problem happens to be 4/5, I'd say 4/5 over 2. Well, this is 2 over 1. Now remember, it's the good old complex fraction. I'd have to invert and multiply. And then that, of course, is going to come out to be 2 over 5, because this reduces out. Then you can say, well, if I were instead to treat it like this, 1/2 times b, this would be 1/2 times b, and b we said was 4 over 5. Notice what I have. I now have the invert and multiply built in. Now I can reduce it down, and I get in the same place 2 over 5. Okay, so here we go. So I want to add something. So I have a perfect trinomial square, x, center sign is plus, squared. Since this is a fraction, I'm going to take 1/2 times b and square it, which is 1/2 times 4/5. Reduced down, I get 2/5. And that happens to be 4/25. But the square root, or what I squared, is what goes here. So it's 2/5. Again, I have another fraction, so 1/2 times b squared is 1/2. b is 9/5 squared, which is 9/10 squared, 81/100. So I've now ruled myself out up there, so I'm going to come down here. Sorry about that. Minus 9/5 times x. I'm going to have to add 81/100. So this is now the perfect trinomial square, x minus 9/10, not, yes, square. That's a perfect trinomial square.